a factoring method. So we've learned all these different ways to factor. How do you know when to use the different methods? So the first thing, anytime you are asked to factor a problem, the first thing you should do, number one, the first step is to find or look, because maybe there isn't one, for a GCF. The first thing you should do is find it or look for it, right? Because maybe there isn't one and you can skip this step. But the first thing you do is look for a greatest common factor. And this works for any size polynomial. This is going to work for any size polynomial. It does not have to be a trinomial. It does not have to be a binomial. It does not have to be 4 terms polynomial. This works for everything. So the first thing you should always do is look for a GCF. So let's do a few examples. If I gave you the problem 4x to the third plus 16x squared plus 16x. Before you start factoring, before you think, oh, I'm going to do one of those methods, X box or the grid or any of that stuff, right? The first thing you do is look for a greatest common factor. So if I'm looking at 4x to the third plus 16x plus 16x, or x squared and 16x, what do they share?
4x.
They can both, all of them can be divided by 4. And they can all be divided by x. So we factor out the greatest common factor. 4x to the third, take out 4x. What do you get? I'm going to put 1x squared. 16x squared, take out 4x, divide by 4x. 16 divided by 4 is plus 4. And x squared divided by x is x. 16x divided by 4x. 16 divided by 4 is x divided by x. Cancels out, right? So there would be our solution. We're looking for a greatest common factor. Looking at this example. Negative 2xy squared plus 8xy minus 17x. What do they all share? They share an x. And there's something else that you need to take out. It's not necessarily that they share it, but there's a rule. If the leading coefficient is negative, change everything. Right? Remember we talked about you cannot have a leading coefficient that's negative. So I'm going to take that negative away. I'm going to take out a -1. So that means everything else changes. What's negative 2xy squared divided by negative 1x? What's negative 2 divided by negative 1?
Positive 2.
Positive 2, right? I change it. If the leading coefficient is negative, change everything. So I take out that negative.
2
The x's cancel out, so what am I left with? Y squared. What happens to positive 8xy divided by negative 1x? Negative 8. The x's cancel out, and what are you left with? Y.
Y what?
And negative 17x divided by negative 1x, what happens there?
Positive 17.
Positive 17, and what happens to the x's? They cancel out. First step you should always do, you should look for greatest common factors, because after you do greatest common factors, then what can you do to this trinomial?
The actual math.
You can factor that into a binomial times a binomial, or try to. A binomial times a binomial. So the first step, look for the greatest common factor. We skip this all the time. We forget that this is step number one. You automatically go into the other types of factoring. So after you complete it, after you look to see if it has a greatest common factor, you'll probably have a trinomial. In the form of x squared plus bx plus c. Or, what's the other way that it's written?
AX squared.
Ax squared plus bx plus c. What did we learn about yesterday?
An easier way to do them.
What did they involve?
Having the seeing if they're perfect squares.
Looking for perfect squares. This could be a trinomial. Or what else could it be?
Binomial.
A binomial. First step is to look for greatest common factor. If there is a greatest common factor, factor it out. If there's not a greatest common factor, you can skip step one. But if there's a greatest common factor, factor it out. Now I have this problem. I can either go the trinomial route, or I can look to see if it's perfect squares. What's the way to factor one of these problems, trinomials?
Divide the factors and see that will add up to bx.
Okay, so you're finding factors of C that have a sum of B. That's for x squared plus bx plus c. If there's no leading coefficient, if it just starts with x squared, if it just starts x squared plus bx plus c, you're finding factors of c that have a sum of b. What if it's ax squared plus bx plus c? X box. What always goes in the top? A times C. What always goes in the bottom? B. Then what? After you do your X, what do you draw?
Two factors.
Your factors go here. Then you draw your box, right? What always goes in quadrant 2? ax squared. What always goes in quadrant 4?
C.
C. And then your factors go diagonally. Is that your answer?
Yes. No, wait, no.
No, then you factor across. Is that it?
And down.
Then you factor down. Could you factor up?
Yes.
This is the one that's going to work the most. This is not a shortcut. You either look for factors of C that have a sum of B, or you do the X box. If you liked yesterday's lesson about perfect squares, you can do the perfect square rules. Let's make a list of perfect squares in here. What are they?
1, 4,
1,
9, 16, 25, 36, 49, 64, 81, 100, 121.
Oops. You look for those perfect squares. What did we discover today during our review of homework? What if the exponents? What can you tell me about exponents? What if you have x to the 4th? What does it break into?
X to the square.
X to the 4th. What times what?
X times X times X times X.
X squared times x squared. What if you had x to the 10th? X to the 5th and x to the 5th. What if you had x to the 7th? What plus what makes 7?
3 and 4.
3 plus 4, are those the same? If it's an odd exponent, it's not perfect. If it's an even exponent, is it perfect?
Yes.
Yes. But an odd exponent is not. But again, do you have to use these perfect squares rules? No. If you don't like the perfect square rules, what can you do? Xbox. It works every time. I mean, if it can be factored. The last one is, what if it's a polynomial?
Oh no.
I'm going to pick a different color. What if it's a polynomial? Specifically, what if it has 4 terms? Jimmy, sit up. What do you do if it has 4 terms? What if it's a polynomial with 4 terms? What's our rule? Damien?
Foil.
Not FOIL. Foiling is to get to that polynomial.
Grid.
Alyssa? Break it in half.
Oh,
Yeah, good problem. 12z to the 3rd plus 48z squared plus 4z plus 16.
That's quite found.
It's a polynomial, multi-terms, and there are specifically 4 of them. So I break it in half. Where's my half line go? Between what and what? Right here, right? Break it in half. 2 terms and 2 terms. What do 12z to the 3rd and 48z squared, what factors do they share? Tony, what? 12. They can both be divided by 12. 12 and 48. And z to the 3rd and z squared can both be divided by z squared. 12 divided by 12 is 1. Z to the 3rd divided by z squared is
4.
z.
Oh, wait.
48 divided by 12 is
4.
plus 4. Z squared divided by z squared cancels out to 1, so I don't need it. Then I look over here. I did the first half, now I go to the second half. What do 4z and 16z share? Anything else? 4 divided by 4 is 1z. 16 divided by 4, so I put plus 4 because it's positive. Did this work out? Yes, because the parentheses should match. I take those out. Is that my answer? What else do I do? I need another binomial, so where does that other binomial come from?
The 4 is
12z squared plus 4. Could you put them in a different order?
Yeah.
All right, what's your first step when you're choosing a factoring method?
5.
Look for the GCF. If there's a GCF, factor it out. If there's not a GCF, move on. How do you know when to do the rules we learned yesterday? The perfect squares rules. How do you know when to use perfect squares? Alyssa? Let's write that in here. If the first and third terms are perfect squares. Is that all? Or the first and last term, I guess, maybe? If those terms are perfect squares, what else needs to happen? Sometimes you have to do 2 times the first times the third. Do you remember doing that? See if that equals your middle term. 2 times the first term times the third term.
Oh, yeah.
If you don't like the perfect squares rules, what should you do?
Xbox.
You should do Xbox. Arlo.
With the probability for the
Mm-hmm.
wouldn't that actually work in the GCF?
Mm-hmm. Yeah. What do you do if there are 4 terms? Break it in half. Factor, factor. Because Arlo, you could do this. Factor this again. Yes, ma'am.
You said in the perfect squares box, if it was